Did you know that the reason tortillas are so nutritious and delicious is because of a chemical reaction? Chemical reactions are everywhere, both inside and outside you. When we cook, when we clean, eat, breathe, move. But it may be surprising to find that most of this huge range of reactions fall into just a few basic types. Esto es Real Chem. Unlike physical transformations, where molecules retain their structure, chemical reactions alter the molecular structure. There are three main types of reactions that we will cover in this course: precipitation, acid-base, and oxidation-reduction. The key to understanding each of the types is thinking deeply about what is happening when the molecules meet one another and react to form something new. Exploremos. A precipitation reaction occurs when two soluble substances in a solution mix and produce an insoluble solid, known as a precipitate. These reactions occur due to strong attractions between the ions in solution, leading to the creation of a solid phase that separates from the solution. Let's look at the reaction between copper nitrate, a blue solution, and sodium hydroxide, a colorless solution. Copper nitrate and sodium hydroxide are both soluble in water. In water, copper nitrate splits into copper ions and nitrate ions, while sodium hydroxide is split into sodium ions and hydroxide ions. When these two solutions are mixed, magic happens. When copper ions meet hydroxide ions, they form a solid called copper hydroxide, which is insoluble in water. This solid clumps together and settles out as a precipitate. So when these solutions mix, they create a visible solid, showing us a classic example of a precipitation reaction. In an acid-base reaction, a hydrogen ion is transferred from one chemical species to another. When mixed together, sulfuric acid and sodium hydroxide engage in an acid-base reaction. Sulfuric acid dissolves in water to yield hydronium ions, while sodium hydroxide dissolves in water to produce hydroxide ions. When mixed together, the hydronium ion and hydroxide ion collide and exchange a proton. The proton is transferred from hydronium to hydroxide, leading up to two water molecules. Reactions such as these that involve a proton transfer are called acid-base reaction. Everyday instances include adding lemon juice to a recipe containing baking soda, or even putting vinegar on a wasp sting to decrease the alkalinity. All these involve exchanging hydrogen ions. Redox reactions or oxidation-reduction reactions involve the transfer of electrons from one reactant to another. Combustion reactions, like burning a candle, burning fuel in a car, are also redox reactions. Your body also uses redox reactions to get energy from the sandwich you ate for lunch. While these specific examples all involve reactions with oxygen, many redox reactions do not involve oxygen at all. Consider, for example, the reaction of potassium permanganate, a chemical commonly used for wood cleaning and general disinfecting, with sugar. In water, potassium permanganate splits into potassium and permanganate ions. When sugar is added, the sugar transfers electrons to the permanganate. The electron transfer leads to the rearranging of the covalent bonds, releasing energy and forming various products, including carbon dioxide and water. The energy is generated so vigorously that the reaction is referred to as sweet fire. Most of the chemical reactions that occur to keep our body in good order, including processing nutritious food like tortillas, fall into a few simple types: But just like simple dance moves can lead to a complex dance number, reaction steps involving transfers of electrons and protons combine to contribute to the complexity of the human body. To begin to understand this complexity, it is useful to first understand how these individual reaction steps occur. Explora y diviértete. So explore and remember to have fun.